Hey, this is Esther, and in this video, I will be making a tutorial on FRQ 2013 number 2 for AP Calculus BC. Okay, so the question says, the graphs of polar curves r equals 3 and r equals 4 minus 2 sine of theta are shown in the figure above. The curves intersect when theta equals pi over 6 and theta equals 5 pi over 6. And so the first thing you want to do is look at the graph they give you. And since this is a calculator problem, if you don't know which one is r equals 3 and r equals 4 minus 2 sine of theta, you can always plug that in to your calculator. But since it's polar, you know that r equals 3 is going to make a perfect circle, and r equals 4 minus 2 sine of theta is going to be the imperfect circle. And then they want you to find the area in between for the first part. Okay, so here I have a rough sketch of the graph that they gave us, and you can break it up into two parts. So there's this orange section which has no intersection between of the two graphs, and it's just the circle. And then there is a green section which is the area of 4 minus 2 sine theta. And so to find the orange section, it's only 2/3 of the circle. So if you want, you can just use the area equals pi r squared. So then you have 2/3 of the circle, pi times the radius is 3 because that's from our equation, squared. And so that gives you the orange section. You can also do this another way by setting up an integral from, you can do 2 times from negative pi over 2 to pi over 6, and then you could find the area, and then it would be the integral from negative pi over 2 to pi over 6 times 1/2 of 4 minus 2 sine of theta squared, and you want to double that. Anyway, I think this is the easiest way to do it. And so you want the total area of the shaded, so then you also need to find the green section, and it just so happens that the green section from pi over 6 to 5 pi over 6 is just where r equals 4 minus 2 sine of theta. And so we know for polar, the equation is the integral of a to b 1/2 r squared d theta. And so what we can do is, since they're both equal on both sides of the y-axis, we can take the integral from pi over 6 to pi over 2 and double that. And then you put your r squared as 4 minus 2 sine of theta squared d theta. And since this is a calculator problem, you don't have to worry about integrating that, and we can just plug it in. And so if we add the orange and the green section, we're going to get 24.709. And so the points for this problem are rewarded on 1, the integral that you write for the green section, the limits and the constants that you use, and then the final point is for the answer. So most of the problem is not finding the answer, but setting it up correctly. And so next we have part B, and part B says a particle moves along the curve r equals 4 minus 2 sine of theta, so that at time t seconds, theta equals t squared. Find time t in the interval of 1 to 2 for which the x-coordinate of the particle's position is -1. So for this one, since we're given it in terms of r, we want to separate that and make it in terms of x. And so to do that, we know that x equals r cosine of theta. So our r is 4 minus 2 sine of theta. And so we just sub that in, and then x equals 4 minus 2 sine of theta cosine theta. And then we want to know when theta equals t squared, so we substitute in t squared for theta, and then we have x of t equals 4 minus 2 sine of t squared cosine of t squared. And if you want to find where it equals -1, you can graph the function 4 minus 2 sine of, we're going to have to plug in x squared instead of t, x squared cosine x squared plus 1, and the plus 1 is just so that when you graph it, you can find where it intersects the x-axis and it equals 0, and then you will have your answer, and it must be between 1 and 2. And so the points on this one are rewarded for making r into x of t, and so substituting in, so you have to remember to substitute in your t for the theta. And another point is rewarded when you set x of theta or x of t equal to -1, because that's what you want to find. And then the last point is for the answer. Okay, so next is part C, and part C asks, for the particle described in part B, find the position vector in terms of t. Find the velocity vector at t equals 1.5. And so what we're going to have to do is separate the polar equation and put it in terms of x and y. And so we already solved for x in part B, and we have x of t equals 4 minus 2 sine of t squared cosine of t squared. And so the same rule applies for y, except for that y of x equals r sine of theta instead of cosine of theta. And so then when we plug in r, we get 4 minus 2 sine of theta times sine of theta. And then we can plug in t squared for theta again, and then we get 4 minus 2 sine of t squared times sine of t squared. And so those are our position vector equations. And so now when we want to find the velocity, we just take the derivative of those. And once again, this is a calculator problem, so I wouldn't worry about all the chain rules that are going to apply for this, and it's probably in your best interest for both time's sake and difficulty level to just plug it in your calculator. And when you do that, you get negative 8.072 and negative 1.673. And so the points for this problem are rewarded for the position vectors, 2 points actually, and then 1 more point for the velocity vector.